Right, chaps. Getting tired, yeah? Okay, but that was 5.1. 5.2, 5.3. I'm going to say just see the memo. Do that on your own. 5.4, I'm going to go through hopefully a little bit quicker than I did the last one with you. It says cos 5p plus cos 3p somehow show that it's equaling to cos 4p and cos p. Okay, so right hand side I'm just going to leave for now. I'm going to work with the left hand side. So the idea here being you've got two coses here. One's a 5p, one's a 3p. Okay, the way I'm going to suggest you do this is that you break 5p up into cos of 4p plus p, and you break the cos 3p into a 4p minus p, right? In that way, you've got 4s and you've got p's, you've got 4s and you've got p's. And in our answer, you've got 4s and you've got p's. So that seems a logical way to go about life here. So now you're going to expand cos 4p, cos p minus sine 4p, sine p. That's that one done. Plus cos 4p, cos p, and plus sine 4p sine p. Okay, happy there. Looking for like terms, you should have a few like terms over here. You've got this guy there and this guy there. They're going to get added together. That's going to give you 2 of them. So 2 of cos 4p cos p. And then this is a minus of that, and this is the plus of the same thing. So they cancel each other out, and look at that, you're equaling your right-hand side. So the decision over here was strategic. We did it on purpose. 5.5, I'm going to go through it with you as well. It's asking you to prove the following, that cos 70 plus cos 50 is equal to cos 10. Okay, similar thing to 5.4, except here you've got numbers, you don't have letters, so left-hand side is equal to, what are you going to make cos 70? It's going to say cos 60 plus 10, and you're going to make this guy cos 60 minus 10. Okay, so you should be getting in the habit of doing that. You're going to expand now quickly. Let's see if you can do this one on your own pretty much by now. Takes a bit of getting used to, but once you've got it, you've got it. I mustn't talk too soon. Watch me make a mistake. Okay, there we go. Done on that side. Okay, remember cos 60s are, and sin 60s for that matter, are special angles. Cos 60 is a half. Cos 10 is just cos 10. Sin 60 is root 3 over 2. And sin 10 is just sin 10. Cos 60 we said is a half. Cos 10 is cos 10. And cos 60 is, sin 60 is root 3 over 2. And sin 10 is sin 10. Cool, we're looking for like terms over here. You've got a half cos x, cos 10, and a half cos 10, which is going to give you 1 of cos 10. And similarly here, you've got minus that and you've got plus that, cancel each other out. That's all I've got, equals right-hand side. Right, 5.6 involves the tan rule. You won't find many tan rules being asked, although don't quote me on that. Often they might just throw it in because it's rare, I guess. So your left-hand side is that, your right-hand side is that. Okay, so we're going to work with the left-hand side as we always do, and we're going to expand it. This one, I guess, just takes some memorizing. So this is going to expand to tan x plus tan 45 over 1 minus tan x tan 45. 45 is a good number because it's a special triangle. What is tan 45? If you check on your calculator, just to make doubly sure, it's 1, so you're going to have tan x plus 1 on the top, and 1 minus tan x times 1, I guess, at the bottom. And it is pretty much what we want it to be. Now we can just rewrite the top, change things around a little bit. Booyah! 5.6 done. Great. We go to number 6. Number 6 says, if triangles A, B, and C, if angles, sorry, A, B, and C are 3 interior angles of a triangle, prove that. Okay, so whenever you see a question like this, I do suggest you just get a bit visual, and you've got 3 corners, A, B, and C, right? There's your triangle. So in 6.1, you are trying to prove that sine C is equal to sine of A cos B plus a cos A sine B. So that's what we're hoping to prove. Right, so now the left-hand side. Instead of saying sine C, what could I change sine C into? Instead of saying sine C, I could say sine of what? 180 minus the total of A plus B. right? Does that make sense? So I'm saying 180 minus the other 2 is the same as saying sine c. Okay, so now we're using our old school cos diagram. 180 minus, we're going into this quadrant. That is sine's quadrant, so that reduces to sine of a plus b. Okay, the old reduction formula. Now we just got our compound angles just to elaborate or expand, and you're going to have that. You're going to have the sines the same, and then you're going to go like so, and sine b. There we are, we're equaling the right-hand side. Okay, so what question does initially look quite rough, actually not too bad. Okay, prove that tan a plus b, oh sorry, the question says if tan a equals 1 and tan b equals 2, then tan a is equal to 3. So we must somehow prove that. So the way to do it is to say tan a plus b is equal to, and using our knowledge of the tan compound angle, that's going to be tan a plus tan b over 1 minus tan a times tan b. Okay, so now they've told us tan a is 1, tan b is 2, so 1 plus 2 at the top, over 1 minus 1 times 2. Okay, so that is going to give you what? 3 over negative 1, right? 3 over negative 1, which is negative 3. There we go, so that's what tan a plus b is. Now we just have to think, what is tan c going to give us? Well, tan c is the same as what? Tan, okay, think carefully, we don't know tan c, but we do know stuff about the a and the b. So we can say tan c is the same as tan of 180 minus a plus b, right? This way, however, going into this quadrant there, remember, is sine's quadrant, not tan. So that reduces to negative tan of a plus b, right? We now know, though, what's that? We now know that tan a plus b is negative 3. So this then is negative of negative 3, which is 3. So now we've proven that tan c is equal to 3. Happy? Cool. I'm going to try squeeze number 7 in, and then we'll carry on with life. Cos, it says here, determine the value of cos 795 without using a calculator. Okay, so cos 795, we can't use a calculator. We can first of all say that cos 795 is the same as what? Cos 75. Why? Because if I have my Cartesian plane and I go full 360, great. I go another 360, that's 720. And then what have I got left to go? If I've got 795 and I've already traveled 720, I've got another 75 to go. So that's just the same as saying cos of 75. Okay, I've just subtracted 720. Cos 75, we can't use a calculator. So what are our special angles? 30, 45, and 60. So we can write cos 75 rather as cos of 45 plus 30. Or 30 plus 45, I guess. Now, knowing our compound angles, cos 45, cos 30, minus sine 45, sine 30. And then we're good to go with our special angles. So 1 over root 2, root 3 over 2, minus 1 over root 2 times a half. Great. I guess at this stage you probably could cheat and just use your calculator, because now it's just simplifying stuff. You could either get root 3 minus 1 over 2 root 2. Okay, that's probably the way you would get an answer without using a calculator, although your calculator probably will summarize it as that. But that we'll know you've used your calculator. Cool, that is 7 done. I am going to stop this video and do number 8 and 9 on another video.